Good morning, good afternoon, good evening. Assalamu alaikum wa rahmatullah. It depends from where you are joining the program. Welcome to InnovatiCS, the Ramadan program. This is a free program that we offer every Ramadan in exchange for $150 donation to any church, any mosque, any non-profit organization, and any family in need. So this program, we are going to learn basic things. Of course, you will need to put some effort to learn more, but hopefully this program is going to help you understand the foundation and understand the requirement, understand what you need to do to be able to change career to whatever discipline you want. And this program, for the first time, we cover artificial intelligence in a nutshell. We cover cybersecurity, we cover cloud computing, and also we cover Python programming. Yesterday we talked about machine learning, and we talked about them in brief, the type of machine learning, supervised and reinforcement. And as a matter of fact, there are over 35 types of learning, but these are the most common learning of machine learning. And within this machine learning comes deep learning, which is a subset of this machine learning, which is a subset of artificial intelligence. So machine learning is nothing but converting the data, any data that we have, converting the data that we have. It could be a text, converting it into a ready or readable format, or format that is acceptable by an algorithm. Machine learning is simply a mathematical algorithm that learns patterns out of the given numerical data. Then learn pattern, apply the pattern on a new. This is historical. History. This is new. And of course we got an output. So this real data, it could be a text, it could be a graph, it could be an audio, it could be an image, it could be video, it could be anything. But the way we treat them, the way we transform them into a readable format is totally different. They are not the same. They go through cycles of pre-processing and filtering and dimensionality reduction until you get the format that is acceptable by a model. That is a machine learning in a nutshell. That is what you will be doing if you were to use artificial intelligence. If you were to use prediction, you will have to convert your data into a data that can be readable, that can be read by an algorithm. So today we are going to move. We are going to learn this week. We are going to learn how to handle text data. How to handle text data. 90% of the data circulating in the worldwide today, it has been generated in the last 2 years only. And I believe 85% of this data is in the text format. Emails, documents, books, whatever you call it. It's all text. And we got two options. Either we need to design algorithms that handle text from scratch, or we need to convert, because most of the algorithms, they are designed around the tabular data that we have rows and columns. So most of the algorithms, they are designed around this tabular data. We have columns and we got rows. Text, we need to convert it into rows and columns as well, and that is what we are going to learn today. And this is what we call NLP, natural language processing. So we'll come to the beauty of the artificial intelligence, and that is NLP. And that is my specialty. Even in my PhD, that was my specialty. So regardless of the data that you will be using for any project, regardless of the type, so the very first thing that you need to do as a data scientist or data engineer or machine learning engineer or data analyst is, number one, you need to spend time understanding the problem that you are going to be working on. If you don't understand the problem, you cannot fix it. You are wasting my time, my energy, my effort, and I would fire you next day. So you will have to spend time understanding the problem. And to understand the problem, you need a team. You need to understand your stakeholders. You need to have a project plan. You need to have a crystal clear objectives. It could be one objective. It could be many objectives. You need to start framing the problem, transforming your problem into quantifiable analytical problem. You need to start building a bank of questions, extracting questions out of the given problem. And there are 4 types of questions. Descriptive questions, like we covered yesterday, trying to answer the questions in the format of when, where, how many. And diagnostic questions, trying in the questions in the format of why. And predictive questions in the format of what is the probability, what is the likelihood, what could happen. And the prescriptive questions in the format of what should we do to make it happen. Then we need to define how we would measure the project. So we have to have a tangible, measurable project. We need to identify what we will be concentrating, or would be studying. Like, for example, if you are working in a bank and your job is to build an automated and intelligent system that determines if a claim is fraudulent or legitimate or right on the fly, what are we trying to do here, or what would be our unit of analysis? Are we trying to should we concentrate on studying the behavior of the client, or the behavior of the transactions themselves, or the behavior of the systems? What are we trying to concentrate? So we need to define the concentration or the unit of analysis. And if we are doing prediction, we need to identify the target variable. Of course, we need to identify approach. Simply by looking to the problem, I can tell you this is the right approach that we should take. And if you are, and also you need to determine if the solution you are working on or the project you are working on requires deployment into production. According to statistics, I believe around 87%, and I don't, but it's around this percentage. 87% of the analytical project fail. Why? Is because they never made it to production. And of course, if you are working on a project that requires deployment into production and it did not make it to production, of course the project has failed. So once you understand the problem, then of course you are going to need to acquire the data. And the data, it could be, as we mentioned earlier, it could be text file, it could be audio files, it could be videos, it could be spreadsheets, Excel files, it could be TSV files, CSV files, it could be a combination, it could be anything. So once you have a hold on your data, then you need to spend time, quality time, understanding this data, understanding every single bit of the data. You apply in EDA, exploratory data analysis, visualizing your data, an image, word, 1,000 of word. When you convert your your data into graphs, you could see something that you might not be able to see when you scan through your data. Applying statistical analysis, applying descriptive analytics, and documenting everything you found about your data. And this report is what we are going to use as data scientists to prepare your data. In data preparation, we need to figure out how to handle duplicates, if any. We need to find out how to handle missing values, al-qiyam al-naqisa in Arabic. We need to determine how to handle outliers, al-qiyam al-mutatarrifa in Arabic. We need to determine and figure out how to handle features with high cardinal features, hierarchical data, how to convert categorical data into numerical data, how to handle the skewness, how to normalize, factorize, binarize. This is not an exhaustive list of what you should do to make your data ready, to make your data looks like this. So this is not an exhaustive list. There are other techniques that you should be able to apply to convert your data into from the raw data, from a data that is not ready yet, into a data that can be understood by a machine. And finally, we are going to have a better version. Of course, sometimes you might need to engineer, extract, create new features out of the existing features. Sometimes you might need to reduce the dimensionality of your data by doing some feature selections. So now we have a better version. We have this version now. We got this version. Regardless of the raw data could be text, could be a graph, could be anything. So regardless of the raw data, now we got a better version, and this version is what we are going to use in the AI, artificial intelligence. So in artificial intelligence, we need to split our data into 80 and 20 or 70-30 or 75-25, and this method is called train test split. This is not only one method that we can use to train our model. There are many other methods, but this is the most common one. Sometimes you need to scale your data. Sometimes you need to identify what to compare your model's accuracy to. And in our case, we start with what we have in the data, which is called base model or dummy model. So we initiate the algorithms, models. We train our model. We test our model. We compare, and we pick the best model. And that one, this model, there's always rooms for optimization through parameter tuning, model optimization. So we are going to get one best model with best parameters, and now if everything goes great, we are ready for deployment into production, and we are waiting for return of investment. So this is so you should create a mental picture of this flow. This is what the best practice of how to conduct an analytical project from the concept all the way to completion. And of course, there are so many things around this, some other extra steps that you might need to apply to make your journey, to make your project a successful project. Okay, so now we are going to move into an NLP. So we are going to start with NLP, but before we do NLP, before we dive into NLP, let's give you an example. Just give you a demo of how beautiful this NLP is. NLP, as a matter of fact, is the foundation of the large language models. Okay, so just to demo the beauty of this NLP, which is natural language processing, that deals with speech and text, but we are going to go with text first. So we have two books, the Bible and the Holy Quran, Holy Bible and Holy Quran. this is not a religious topic or lecture simply, and I'm not interested in comparing these two books from the religious perspective. Simply wants to demonstrate how great NLP is if used right. So we got two books. We want to compare them using NLP. We want to study them, dive deep into the main theme of them using natural language processing. And unfortunately, Professor Ed is going to teach you Python towards the end of the program. So this is not a Python session, but I'm going to simply go through this. So the first thing we got to do is import all the libraries that we need, and this is available online. Import some processing techniques. Then we are going to read the Quran, and this is not the Quran. This is a translation of the meaning of the Quran. So it's not the Quran. It's translation. And it has 860,923 English word. Then we are going to read the Bible. It has 4.5 million. Then now we are going to visualize the concept of the Quran versus the concept of the Bible using one library. It's called Word Cloud. And this is the Quran. This is the theme of the Quran. So let's take a look. So what this graph represents, the most frequent word of the Quran. We got God, we got will, Lord, say, they, people, said, and of course, some of these words, they have some root, something in common. They have a root, like for example, the word said and the word say should be one. Will, and we got some words that probably don't have any analytical value, like for example, thus, where, how, anything, everything, for, a, the. I mean, they don't have any value, so that is what we call stop words, and we need to remove stop words later. So this is the Quran. We could zoom in and zoom out. Let's zoom in another time. And here this is a clear picture of the entire translation of the Quran in one big image. And you see the focus. The focus is God, and followed by messenger, people, believe, earth, truth. These are some of the Lord. So we might need to convert Lord to God because they are the same. And yes, so we got another God in there that we need to convert. I think it comes with an apostrophe. So few things that we need when we are dealing with the text. We need to remove from a text. Like for example, we got this Yahoo. We want to analyze this article, for example. Yeah, we want to analyze this article. So few things that we need to analyze this text. Few things that we need to do. Number one, we need to remove. We need to transform everything to lowercase. Lowercase to avoid any duplication. Number two, we need to remove punctuation. Number three, we need to remove any punctuations, special characters. Number four, we need to remove numbers. Number five, we need to remove what we call stop words, like for example, at, for, a, into, a, of, on, a, to, a, of, etc. This is called stop words. Number 6, we need to remove spaces or white spaces. Number 7, we need to keep only, it's called lemmatization or stemming. We need to stem or lemmatize. In other words, keep only root. For example, if we have a word love, loving, these three, they are three distinct words, but actually all of them, they mean to be, they have a root word love. So we need to transform everything to the root using either stemming or lemmatization. And finally, we vectorize. So these are some of the steps that we need to apply to any text to convert it from raw data to a data that can be used, that can be utilized, or they can be used for machine learning. So now let's move into the Bible. So this is the Bible. Again, as you see, they have some common words like said, God, Lord, and God, and of course we got a lot of stop words like until, and this is King James version, which is using an ancient English, Old English, until, thee, put, think, yea, thou, shalt, thy. All of this, they are stop words. We need to remove them before we compare the Bible to the Quran. So we are going to remove all these punctuations, and we are going to remove this. We process the data by removing punctuations, removing numbers, removing the special characters, removing stop words, removing the white spaces, and also converting, keeping only the root through stemming and lemmatization. Okay, let's do that very quick, then we are going to move into the lecture. So I'm gonna drive very quick. I simply want to go to the end result, show you how I compare these two holy books. So here is the Quran, and this is the most frequent, or the Quran in the frequency. The most common word in the Quran is God. Okay, it's God, followed by people, they, believe, err. These are the most common words of the Quran. God's, one, etc. Okay, now let's take a look into the most common word of the Bible. Is again God, man's, Israel, make, son, king, people. So my finding is 95% of the Quran and the Bible, they are identical. They are identical, which demonstrate that they are from the same source, regardless of our religious belief. That is the beauty of an NLP. Comparing, extracting, diving deep. It's really an amazing discipline within artificial intelligence and data science. Okay, so how this NLP works? What is an NLP? So an NLP is the science of studying speech and the text, the natural human language, using artificial intelligence, of course. So NLP is a branch of computer science and a branch of artificial intelligence concerned with giving a computer the ability to understand text and spoken words. So text and speech. That is an NLP. So NLP has two components, NLU and NLG, natural language understanding. You get a text or a speech trying to understand this the content of this raw data, and NLG is trying to extract or generate new content out of the given content. So three component or three part that got involved, three ingredients are involved in NLP: computer science, artificial intelligence, and of course linguistics. So NLP starts, it's not something new. And NLP starts back, NLP went through five major eras. Before 1960s, then from 1960s, 70s, 80s, 80s, 2000, and 2010, and present. So from 1950s to 80s, it was a linguistic, or rule-based systems. So we build a system. If it's this, do that. If it's that, do this. If it's this, do that. It's all conditional rules. That system, they work well, but unfortunately, they are too complex to maintain. We got thousands of F and L FLs around the path, and if anything goes wrong, you wouldn't be able to figure out where to go in the code to fix it. And it does not scale. It works only for static data. If you were to bring new data, it wouldn't work. And you cannot predict, you cannot generalize. So that is the era, or the first period, or the first era of NLP that we used the rules and linguistics. Then the second era is from 1980 to maybe 2010. This is where we designed corpus. Corpus is the collection of the searchable documents. And in this era, we apply statistical analysis, statistical method, of course, including supervised, machine learning, supervised, unsupervised, etc. Then, from 2012 to almost 2020, we dive into deep learning. Deep learning, which goes deep into the character level of a word. Not only a word, but the character level of a word. And from 2020 to 2025 to 2024, now it's large language models with the transformer and the intention transformer. So it's one, and it's of course this large language models. They didn't come from nowhere. They were built on the top of NLP. They have been in the market since maybe late 1950s, but it went through a process of development, a cycle of development. We started with rule-based systems, into corpus and statistics, into deep learning, into large language models like ChatGPT and Bard of Google. Okay, so this NLP that can be used for getting the insight, product insight, learn what customers are telling about you. If you have a website that and you are offering feedback from your client, you could use NLP to learn about your client feeling right on the fly. It could be used to monitor for security monitoring. Imagine that you have a system that manages millions of emails or texts. So you could detect a potential risk right on the fly using this NLP without going through the entire documents or entire messages or entire data. You could use NLP for clustering. So you got two emails, which one is a ham, which one is a spam? Spam, yes or no? You could use NLP, of course, to identify a pattern within a given text or a given speech or a given raw data. So it's a multidisciplinary discipline. So you could use it in many disciplines. You could use it in spam filtering, speech recognition. I can tell if this text belongs to someone. I can tell if this speech is yours, is this voice is yours or someone else. We could use it for sentiment analysis. How do you feel? What do you feel about my product or my service? And fix it right on the fly. We could use it to promote, cross-sell, upsell, and use it for recommendation systems. NLP can be used for many applications. It could be used for text summarization. You got a book, you want a summary of the book in 5 sentences. You could do that. You could use it for topic modeling. You could use it for text generation like ChatGPT. You could use it for sentiment analysis. You could use it for risk management, compliance and risk management. You could use it for entity extraction. You could use it for synthetic data generation. And of course, you could use it for customer service. You got one agent in your company, and this one agent only can serve one person at a time. And this one person would take you at least 30 minutes. What if you have 300 people in line? How would you serve them? The chatbot, what they do, they are smart agent, probably maybe more smart than sometimes than humans, but they can serve all these 300 clients. They are waiting on line around the clock at the same time, without any break, without any delay, and much better sometimes than humans. Of course, there are some questions that might not be addressed by the chatbot, so we need the humans to jump in. But these are some of the applications that you could apply NLP once you master the NLP. Okay, NLP also, as I said, can be used for machine translation, question answering, information extraction, sentiment analysis, and information retrieval. It is a must-have. NLP is a must-have under your belt if you want to be a superhero data scientist. So there are 5 levels of NLP: lexical analysis, syntactic analysis, semantic analysis, discourse analysis, and pragmatic analysis. All of them related to NLP, and every type of analysis deals with certain elements of this text. Like lexical, it analyzes the word structure. Syntactic analyze the grammar and sentence for grammar error check. Semantic and analyze the meaning of a word within the sentence, within the paragraph. etc. So NLP, as I said, deals with a speech or a text. So if it's text, we will be analyzing the morphemes, which are the unit, the smallest unit of a text. And for speech, we analyzing the phonemes, which are the smallest unit of any speech. And of course, we apply all the 5 analytics. We apply the lexical, syntactic, semantic, discourse, and pragmatic to either morphemes or phonemes. For information retrieval, sentiment analysis, information extraction, questioning, answering, and machine translation, etc. So talking about the component of NLP, there are 2 components. NLU, understanding what you have, understanding your data, understanding it, driving the meaning, trying to get the meaning of a word, the meaning of sentence, meaning of a speech. We are not generating something new. We're simply trying to understand what we have. And an example of this NLU. So you got a document, some documents, and we want to classify them as you want to classify emails as a spam or no spam. We want to classify movies as a positive or negative. We want to classify some documents as legal documents, relevant legal documents, or not relevant. So we have a data. This is another terminology for what we call discriminative artificial intelligence. So we got a data. We're trying to extract something out of that data. We are not creating anything new. We are using the data that we have to make a decision. And all what we're trying to do here is understand what we have and make a decision upon it. So we could use this NLP, NLU, to show relevant web page based on a query. Sometimes you search on something next day, or you talk to someone about something, right at the moment you check your social media or your email, you got an advertisement relevant to what you have discussed with someone. So we use it, understanding what you need, we can serve you better, and we can understand what you need using NLP, using the NLU of the NLP. So recommend news article based on a past article, recommend restaurant based on Yelp review. We could use NLU for document recommendation. We could so this is some of the examples of NLU, which is a component of NLP, natural language understanding. The second component is natural language generation. Now we generate. So ChatGPT is NLG, natural language generation, but it requires NLG, natural language process generation is not going to work without NLU, natural language understanding. You cannot generate if you don't understand. So we will have to analyze the existing data, either speech or text, using syntactic, semantic, lexical, pragmatic, etc. analysis, understand what we have, then determine what to generate. So for this NLG, some examples: image captioning. You got an image and you want to generate a description of that image. Text summarization, we got one paragraph, we convert it into a short paragraph. Machine translation, you got a text in Arabic, then we convert it into English and vice versa. Question answer, you ask a question, you get an answer, and much more. Here are some example. Now this is an automated caption generation for images. So we feed this image into a system. Then we got a caption describing what is in the image at a certain level of accuracy. Okay, so we have here, we got an image and we generate a text, and vice versa. We got a text, we can generate an image. That is energy, one of the energy application. Energy application can be used in translation. We got English transform into Spanish or convert into Spanish. There are few existing algorithms. Google Neural Machine Translation System, JNMT, and Google Phrase Based Machine Translation, PBMT. So when we comparing for English to Spanish, we are comparing humans to the JNMT to the PBMT. You see they are very close. Machine is very close in terms of translating, close to human translation in terms to translating English to Spanish. English to French, the same. English to Chinese, we are too far. Machine, they are too far from humans. In French to English, you see humans and JNMT, they are almost identical. So this machine, these systems, they've been improved across the time, and maybe one day we could get a better translator machine systems, better than humans. So we don't need humans to translate anymore. And all those linguists, or if you are looking for a job in translation, if your expertise is translating one language to another, maybe you might need to think twice, because this type of jobs might not exist in the future. So this type of jobs could be replaced by a system, once of course we get them mature. Okay, so text summarization, we got a paragraph, we convert it, or so we got the paragraph, we got something new. We generate a summary in less than 7 words. We got another paragraph, we got the summary in 1, 2, 3, 4, 5, 6 words. So we generate new outcome out of the existing income. Okay, so simply I'm going to skip. So again, as I said, 80% of the data being generated within companies is in text format, and 90% of the word data is unstructured data. Unstructured data. So it's all text and speech, images, audios, etc. So we need to learn how to convert this text, this data into a tabular data, into a data where we have rows and columns. So the process of converting a text or a speech into a knowledge, it starts with raw data. Then we pre-process this data. Pre-processing means we remove special characters, we remove numbers, we remove punctuations, we remove white spaces. We stem and lematize, means we keep only the root. Then we vectorize. Convert into rows and columns. That is what we call vectorization. There are many methods to vectorize a text. Some vectorization capture the syntactic, semantic of a word. Some vectorization method only capture the syntactic of a word. Then after we vectorize, we need to reduce the dimensionality. We need to reduce features. We cannot use all the features. So we need to reduce the dimensionality, and after that we apply machine learning. we apply artificial intelligence, supervised and supervised, then we find something meaningful that we can use, that we can share with the business for informed decision management, informed decision making. So that is the roadmap, that is the map of converting ethics data into a knowledge. Okay, so the way it works in this text pre-processing, so we got raw data. The one thing that we gotta do, the very first thing, is we need to tokenize. Tokenization is nothing but identifying out of this text, is splitting this text into the smallest unit called tokens. So this is one, this is another one, third token, fourth, fifth, etc. And why do we need to tokenize? Is to be able to navigate through every single unit. So we are going to go to the first, add. So we are going to navigate through using the loop. We are going to loop, we are going to go to add, and we are going to ask it, are you lowercase? Yes, convert into are you uppercase? Convert into lowercase. Are you punctuation? No. Are you a special character? No. Are you a number? No. Are you stop word? Yes, remove. Then we do the same to the list, sex, people, remain. So tokenization helps us to navigate through the smallest unit of our text and compare them with what we need to remove. So we are going to compare these tokens into punctuations, a list of punctuations, list of numbers, list of stop words, and of course if they match, we remove them. So the very first thing that we gotta do is tokenize our text. And there are two types of tokenization. There are word tokenization, means split the entire document into smallest unit, words, punctuation, etc., called the tokens. Or sentence tokenization is split the entire document into sentences. And how do we know if it's a sentence? Is by the full stop. So it goes through the entire paragraph and then split by the full stop. So once we tokenize, then we are going to remove stop words, of course, including punctuation, white spaces, numbers. Then we stem. Stemming means keep only the root, and I gave you an example earlier. Love, loved, loving. All of them, they have one word, which is love. So we are going to remove ing, we are going to remove ed, suffixes and prefixes of word, and keep only the root. And there are two ways of doing that through stemming. Stemming, it looks for a word without, out of the meaning. It's simply using the syntactic analysis, and it finds the word, it removed ed, ing, etc. But it does not care about the spelling. And it's fast. And there is another one, it's called lemmatization. Lemmatization is slow because it looks for the root of a word using the syntax and syntactic analysis, and it also looks for the meaning, and it compares the word with an online dictionary for spelling correction. Then we normalize. And after that, and the final tokens now can be vectorized through TF-IDF is one way. As a matter of fact, there are many methods. I got a document I can share with you. You could use This is simply a guide, vectorization NLP. We could use one-hot encoding, we could use bag of word, we could use TF-IDF, and some of these vectorization method, they capture the semantic, and some of them they don't. Like for example, the cat eats food and the food eats cat. Their vectorization is the same if you were to use, for example, bag of word. But if you were to use TF-IDF, probably you are going to get this. You are going to get different because TF-IDF, it captures the syntactic and semantic part of a word. Okay. So here is the pipeline, or here is the map. We start with tokenization. We remove stop words, punctuations. We remove words, white spaces, special characters. Stop words is any common word like the, where, when, how many, what. So they are common words. They don't have any statistical meaning, any statistical analysis, or any statistical influence. Then we stem, we keep the root. Then we study their tagging, and of course we use the remaining word, or the final product, for information retrieval, for knowledge. Tokenization, here is an example. So we got this, we got two tokenization techniques, or methods. We got sentence, and we got the word. So we got here hello word. This is a sentence tokenizing. If we were to tokenize it using token sentence, now we got hello word, comma. We got this is a sentence tokenizing, full stop. If you were to do the opposite, the word, so we are going to get hello. This is a token, word is a token, exclamation mark is another, this is word, tokenizing, and full stop. And if we were to remove, if we were to pre-process this, we are going to, definitely you are going to remove this exclamation because it's a special character. This is a stop word, is simply a verb, word, tokenizing, and full stop. So we are going to end up having hello, word, tokenizing. And of course with tokenizing we need to remove ing, and we are going to end up having hello word tokenized. And based on that we can extract the knowledge. That is called tokenizing. Tokenization. Tokenization is splitting or breaking your text into the smallest unit called tokens to help us navigate through them for data preprocessing. Stop words removal. Here is a list of some of the common stop words like a, about, above, after, again, against. This is all stop words that we need to remove. They don't have any value. They might slow down your computation process if we were to keep them. So we remove them because they don't have a value. Stemming is removing, keeping only the root of a word. Like for example, we have here helps, helping, help, helper. So, but they have one stem, they have one root, that is help. If we were to keep them all, the system understands them as five unique words, whereas they are actually one unique word. That is called stemming. And stemming, it simply uses the syntactic analysis, and you will end up, it's fast, and you will end up having a lot of misspelling. And lemmatization is a better, it does use morphological analysis or pause of word. So like for example, so and so, it can convert them to their original format. loving and loving, love. It's called love. So it's very slow because once it finds the root of a word, it compare it to an online dictionary for accuracy or for spelling correction. Okay, folks, I think unfortunately we gotta stop here, and we will continue tomorrow from where we got left. So I'm gonna stop here for now, and I'm gonna open the floor for questions. So if you have any question, any concern, any doubt, please raise your hand, and I will be more than happy to address your concerns. Questions? Okay, folks, that's it for today. I'll see you guys tomorrow. Until then, you guys have a great evening. Bye, everybody. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.